These are your 8.1b notes, adding and subtracting polynomials. So we're going to just build off of what we did from 8.1a. We're going to still be working with polynomials. We're still going to be putting them into standard form. But today we're actually going to take it a step further. We're going to add and subtract the actual polynomials. You have practice with this. We've combined like terms when we were solving equations. So it's very similar to that. The catch is, now that you guys know how to multiply and divide these things, you're going to want to do things that you're not allowed to actually do. You're going to break some rules. So now that we learned in the last chapter how to multiply, some of those things are going to be a little tricky when we get into adding and subtracting. So there's two different ways to add or subtract, but in both cases, you're going to add or subtract the coefficients of the like terms. If you remember, way back when we did distributing, like terms have the same variable raised to the same degree. So a 2x and a 3x are like terms because they have the same variable x raised to the same degree 1. An x squared y and a 5x squared y are like terms because they have the same number of degrees raised to the same degree. So x was squared, y was to the first. If I put a negative in front there, that just means a negative 1. If I switch the order, even a 3y x squared is considered a like term of that set because it still has a y to the first and an x squared. They are all three like terms. And of course, just something simple, a 2 and a 7 are like terms. They don't have any variables. They both don't have variables, so they would be considered like terms. Okay? When you do this, you do not change the degree of the monomials. You're simply telling me a total. You're telling me how many of those x's you have. How many total x squared y's do you have? Okay, so if you look at, just really quick, from before, this should be old information. If you have 3x squareds and you're adding 5 more x squareds, you should have a total of 8 x squareds. It didn't change into an x to the 4th. I am just telling you how many x squareds I have total. Okay, and if you want to think of it in a visual sense, I have 3x squared sitting over here. Right? Here they are, my 3x squareds. And then somewhere else, I have 5 more x squareds. I'm just circling them so I can kind of show you that they're an actual item. So if I were to push all of these three, well, if I were to push all 3 of these x squareds over with these 5 x squareds, I have a total of 8 x squareds. Okay? And just as well, if I have 3 of something and then I take away 5 of them, I am left with negative 2 x squareds. X squared just represents something, an amount. We don't know what that amount is, but it doesn't change. It doesn't become x to the 4th. We are not multiplying these things. I think of it like you're sweeping them in a pile. Okay? And we talked about birds of a feather, so I have 3 birds flying over here. I have 5 x squared birds flying over here. I have a total of 8 x squared birds flying. I have 3 here, minus 5. Think of money. I have $3. I spend $5. And so now I'm in the hole $2. Think of football. I gain a gain of 3 yards, and now I lost 5 yards. The total gain or loss is a loss of 2 yards. So that's all stuff from first semester. So what we're going to do is we're going to do that, but we're going to do it several times with several different terms in the same problem. So one of the ways to accomplish this is using a vertical alignment. Vertical method is kind of like old-fashioned addition and subtraction from grade school. So you align the like terms vertically. You put x squareds underneath other x squareds. You put x to the 4th underneath x to the 4th, constants under constants. And then you add or subtract like you would. Now, subtracting is a little different because when you subtract, you're subtracting every single term inside those parentheses. So you can subtract, it's a little different. Or what we do a lot of times in algebra is we just add the opposite, change the sign and add. Okay, when we work with positive and negatives, that's an approach. When you have to subtract negatives, you change the sign to an addition, and then you change the value of the second number. So it's the same concept here. Now, kids get confused because there's parentheses around these things, and that's a little misleading. When we see parentheses around a group of numbers, we think multiplication. We think of multiplying these things. Well, one clue that we are not multiplying is there's a great big addition sign in between them. Okay? So we are not multiplying these things together. We are adding them together. Why are the parentheses there? They are basically telling you where one polynomial starts and stops and where the other one starts and stops. So we have a polynomial here. It's actually a trinomial of 3 terms, and we want to add it to this trinomial afterward. So the parentheses are just telling you what polynomial represents one number and what polynomial represents another number. Okay, so you can kind of rearrange them in order. You can put them in standard form first, or you can put them in standard form as you go. So I'm looking at the very first problem, and I see that 7y squared is the first highest degree, and then plus 2y and minus 3. So underneath it, I'm just going to match up those like terms. So I'm going to look for a y squared in the second quantity, and I see a positive 5y squared here. And then I'm going to look for another y, and I see it here, so I'm going to put a minus 4y here. And the plus 2 is going to go underneath the negative 3. Now the operation was addition, and so I'm adding all of these things. Some of them are positive and some of them are negative, but it's fine. It's almost like a system of equations back from first semester. So I have 7y squareds, and I add 5y squareds. I'm left with 12y squareds. I have 2y, and I take away 4y. I am left with a negative 2y. And I have a negative 3, and I add 2 to it. I get a negative 1. So this is your sum of those two polynomials. You're just creating a more simplified approach at looking at those two monomials. When we subtract, same concept, we're going to realign them in standard form. So I'm going to look at this first one, and I notice that ay to the 4th is the biggest degree, so I'm going to put that out in front, followed by a positive 6y squared. If there's no sign out in front, it's a positive, and then minus 5y. And now what I notice in the other problem, I'm just looking, and I realize there's a constant in the other problem, but there was no constant here. So I'm going to put a plus 0 here as a placeholder so that when I put the 7 there, that I know where I can put it. It'll line up nicely. And I notice that the second polynomial doesn't have a y squared. So I'll just make sure I put, it does have a y squared, it doesn't have a y. So I'll put a 0y where the y's go. So I'm going to look for y to the 4th. I see a 9y to the 4th. And I'm subtracting these, so I'll change that in just a second. And then my positive 2y squared goes underneath my 6y squared. There is nothing for my y value, so I'm just going to add a 0y. And then my negative 7 is going to go underneath the 0. Now subtracting these gets a little confusing because a lot of kids will forget to go back to the subtraction sign. They'll subtract the 8 and the 9, but when we get way down here, they forget to subtract the 6 and the 2. So you'll get a lot of 8s when it's actually 4. So a trick for that is distribute that negative through this whole second number and make an addition. Add the opposite. So what you'd have is ay to the 4th plus 6y squared minus 5y plus 0. And on the bottom, you'll have a negative 9y to the 4th, a negative 2y squared, a negative 0y, and a positive 7. And our sign, our operation will be addition. It's sort of the same concept as when we did systems of equations. We'd multiply one of them by a negative 1, so we could add. Same concept. So I'm not going to use this one anymore, and I'm going to just go through this process of 8y to the 4th, take away 9y to the 4th, leaves me with a negative 1y to the 4th, or just a negative y to the 4th. Positive 6y squared minus 2y squared leaves me with a positive 4y squared. Negative 5y, take away 0y, is still a negative 5y. And 0 plus 7 is still positive 7. So this is the difference of those two trinomials up above. And that's vertical method. You can align the numbers vertically. Okay? Another way to add is to do it horizontally. So the horizontal method is in which you distribute a positive or a negative 1 through the parentheses so that you no longer have boundaries around your 2 polynomials or 3 polynomials. So in example 3 here, if you look at example 3, I would put a little 1 on the outside of this parenthesis set, and because it's positive out in front, I'd distribute a positive 1. All that will happen is my parentheses will disappear, because when you multiply by 1, it doesn't change the value, it'll just get rid of the parentheses. And then outside the second set of parentheses, I would actually distribute a negative 1. If it was positive, I'd actually distribute a positive 1. And all that's going to do is change the sign of all the numbers. The numbers themselves, the 3s, the 7s, and the 9s would stay the same, just the sign would change to the opposite. And then what you can do is you can regroup and combine like terms. Now the regrouping part, some of you guys might want to physically regroup them, and others maybe can regroup in their head. It's going to depend on how well and how comfortable you feel with that information. So I'll show you both ways. And then I believe this method works best if you have more than 2 things that you're going to be adding or subtracting. The vertical method can kind of get a little messy and a little long that way. This is usually the preferred method as we go through algebra, but if you like to line them up vertically, I'm okay with that too. So if you look at number 3 here, we got when I distribute a positive 1 through, I'll get one great big polynomial, 4x squared minus 2x plus 7. And when I distribute the negative 1 through, I'll get a negative 3x, a positive 7x squared, and a positive 9. So what that does is it takes away the barriers of a trinomial, take away another trinomial, and it opens it up to one great big polynomial. Now, if you want to regroup, physically regroup and write them down, you can make your new groups. You can take this 4x squared and group it with any other x squareds in the problem. And it looks like there's just this positive 7x squared right here. So I keep the sign and I put them together in parentheses. And then I can find another group of numbers for my x values. I have a negative 2x. I'm just adding to it a negative 2x and a negative 3x. And then another group of numbers, I can add to that a positive 7 and a positive 9. So I just grouped together, physically regroup them. And so what happens is a 4x squared and a 7x squared makes 11x squared. A negative 2x and a negative 3x makes a negative 5x. So plus and minus makes a negative. And then the 7 and the 9 makes a positive 16. And there's your answer. 11x squared minus 5x plus 16. Another way to do that same problem is to maybe just use colors to regroup. So I'm going to work back with, right after we distributed, I'll show you what else you can do. Maybe you want to use different colors or maybe different shapes. So maybe what we want to do is instead of regrouping them underneath, I look at 4x squared and I circle it. And wherever I see another x squared, I might circle that number. So I know that the two circled numbers go together. A 4 and a 7 make 11x squared. I'm done with the x squareds. Then I go through and I see this negative 2x. You got to be careful that you can still see your signs. And then a negative 3x. I know that I have a negative 2x, a negative 3x makes a negative 5x. And maybe I want to use a triangle or a cloud or whatever. So I have a positive 7 and a positive 9, makes a positive 16. So that's another way to do the same exact problem, just grouping together the like terms without actually writing them next to each other, grouping in your head. You could use highlighters to highlight in different colors, you could underline in different colors, or you can just go for it. So As long as you get the right answer, I'm okay with that. If you start getting the wrong answer and you're not showing enough work, maybe you want to step back and show a little bit more work. All right, let's try number 4 here. So again, we got a positive 1 outside here and a negative 1 outside here because it's a subtraction. So this first group, when I distribute a positive 1 through, I'm going to get a 6n squared plus 11n cubed plus 2n, just gets rid of the parentheses. And then when I distribute a negative through this set of parentheses, everything's going to change to the opposite sign. Negative 4n, positive 3, negative 5n squared. Regroup. I see 11n cubed. It's the highest one, and it doesn't have anybody else, so it's done. I see a 6n squared here with a negative 5n squared here. I'll group those two together. I've got a positive 2n and a negative 4n that I can group together. And then I have a plus 3. And so the 11n cubed just stays 11n cubed. A 6n squared and a negative 5n squared leaves me with positive 1n squared. A 2n and a negative 4n leaves me with a negative 2n. And then a plus 3. And so that's your final answer, your difference, the subtraction. If you wanted to, again, you could use highlighters. And so I could say that I have a, in the original problem, I have a 6n squared with a negative 5n squared. I have a positive 2n with a negative 4n. I have a positive 3 all by itself. And I have a positive 11n cubed all by itself. So the colors can help out too. I don't care. I'm open to any of those methods. One more problem. We're going to find the perimeter of the triangle. So to find the perimeter of a triangle is talking about the outer boundary of the triangle. So perimeter is going to equal all the sides added together. So a 2x squared minus 3 plus an x minus 5 plus a 7x squared plus 4x. Now, a lot of times in the book, they'll already have parentheses around them. I kind of put the parentheses around them on accident because we really just need to take them back off, right? So if I were to use one of these two methods, because there's more than a number that we're adding or subtracting, I would just do the horizontal method here. So we're going to distribute a 1 through, a positive 1 through, and a positive 1 through. So I kind of made this problem a little bit longer than it needed to be because I put the parentheses in it. So we end up with 2x squared minus 3 plus x minus 5 plus 7x squared plus 4x. I will tell you, slow down. You're going to make sign errors. You're going to do addition and subtraction errors because you rush. So take the time, give enough time to signs that you do numbers. Okay, so the number gets just as much attention as a sign, and the exponents take care. Algebra is going to make you really slow down. So if I look at this, I'm going to regroup them. I'm going to use the highlighter method. I've got 2x squared here, and I've got a positive 7x squared here, so I know they're going to go together. I see a positive x here and a positive 4x here, and I see in pink I can do the negative 3 and the negative 5. So the biggest one are the blues. So I'm going to add those together first. A 2x squared plus 7 more x squareds gives me a total of 9x squareds. Remember, the exponent doesn't change. I have 1x here and 4 more here. So I have a total of 5 x's. And then negative 3 and negative 5 makes negative 8. So this would be the perimeter of that triangle. All right, that's it for today. So first of all, I'd like to know what method you prefer, whether you like the vertical method, the highlighter method, the regrouping, horizontal method, which method you like. And I just have one problem for you to solve. If it will show up, it's not showing up. There we go. I need you to subtract those two. You can use any method. Just make sure that you show your work.